Hi there, hope you have a fantastic day today. This lesson I will teach you integrations involving trig functions. Of course, there is a PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Let's say I have a functions y is equal to psi of x. So y is equal to psi of x. If I differentiate this, so that is dy dx, and we know that differentiate psi, it will give me cos. So that will give me cos of x. So therefore, if we integrate going backward, we integrate cos of x dx. So that will give us psi of x because we're just going backward. That's all. So that is psi of x. And because of indefinite integrations, so we need to add a constant. So that is c. So therefore, integrate of cos of x dx is equal to psi of x. Okay, please keep that in mind. And how about, so y is equal to cos of x. And we know that if we differentiate cos of x, will give us negative psi of x. So dy dx is equal to negative psi of x. So in another word, if I integrate negative psi of x, it will give us cos of x because we're just going backward. That's all. So integrate negative psi of x dx is equal to cos of x. And if you think about it, okay, because of negative here on the left hand side, if I times negative 1 on both sides, we times negative 1. So these two negative combined will give me a positive. So in another word, if I integrate psi of x dx, and then negative 1 times cos is negative cos. Okay, so that becomes negative cos of x. So therefore, integrate sine of x dx is equal to negative cos of x. And don't forget, we need to add a constant because of indefinite integrations. And how about if we have a function that is y is equal to tan of x. So tan of x, y is equal to tan of x. And we know differentiate tan of x is sec square of x. Okay, keep that in mind. So dy dx will give me sec square of x. And now if I integrate sec square of x, so if I integrate sec square of x dx, that just going backward. That's also will give me tan of x. Again, because we are working on indefinite integrations, so we need to add a constant. That is plus c. So there you go. So please keep that in mind. Integrate sec square of x, it give me tan of x. And if we integrate sine of x, will give us negative cos of x. And if we integrate cos of x, will give us sine of x. Okay, please take note on this. Let's add a little bit of flavor. So let's say if we have a functions y is equal to sine of ax plus b. And if I differentiate this, so that is dy dx is equal to, we differentiate the power, but in this case, there is no power. So we differentiate the angle. So differentiate the angle first, give me a. So therefore, we just write 8, and we times differentiate the trig functions. So the trig function is sine of x. So differentiate sine, give us cos. So this is cos, and whatever the angle is, we just write this down. In this case, is ax plus b. So there you go. So therefore, if I integrate this, so if I integrate a cos of ax plus b dx, so that will give me sine of ax plus b. So that's what that meant. Okay, we've just gone backward. So therefore, if I divide it by a on both sides, so let me just divide it by a on this side. Of course, I need to divide by a on this side. So that cancel out. So therefore, if I integrate cos of ax plus b dx that will give me sine of ax plus b over a. This is exactly the same as 1 over a sine of ax plus b. Again, because of indefinite integration, so we need to plus a constant, that is c. So that's all. So let's just go through a couple examples on this. Integrate cos, let's say 2x plus 5 dx. And we know that a, okay, is 2 here. So therefore, we integrate this, will give me 1 over 2, because it's 1 over a. A is 2. So therefore, 1 over 2. And then cos becomes sine. So sine of ax plus b. So a is 2. So 2x and plus b. B in this case is 5. And then don't forget, we need to add a constant. So that's all, right? So let's go to one more on cos. So if I integrate cos of, let's say, x over 2 plus 3 dx. So therefore, in this case, x over 2 is exactly the same as a half x. Let me just rewrite this. So this is exactly the same as integration of cos of a half of x plus 3 dx. Because x over 2 is exactly the same as a half of x. So in this case here, a is a half. So therefore, 1 over a means 1 over half. So 1 over half is just like 1 times, we flip the fractions. So become a half become 2 over 1. So 1 times 2 over 1 is 2. So the answer is equal 1 over a, so become 2. Otherwise, you can just write 1 over a half first. Or easier, you can even write 0.5. And then that should give me 2, right? So I just quickly write 2 down because I know the answer. And then this cos becomes sine. We just apply this rule here. So 1 over a. So 1 over 0.5 give me 2. And then now I just write down sine of ax plus b. So a half of x plus b. And b is 3. And we need to add a constant. So there you go, right? So how about if we have a functions? So let's say y is equal to cos of ax plus b. So again, we differentiate the functions. So we use power angle trick. So dy dx or y dash if you like. So we're doing the power angle trick. So we differentiate the angle. In another word, we differentiate ax plus b because that's an angle. So give me a. So we go a. And we differentiate cos, give me negative sine. So we just time by negative sine. So I put a negative in front. So sine of whatever the angle is, I write this. There you go. And then power angle trick done, right? Because there's no power. So I differentiate the angle and then I differentiate the trick. So there you go. So therefore, if I integrate this, so if I integrate negative a sine of ax plus b dx, so that will give me cos of ax plus b. And don't forget, we need to add a c because we are dealing with indefinite integrations. Now, if I divide by both by negative a, so if I divide this by negative a, I divide this by negative a. So this cancel out. So in another word, if I integrate sine of ax plus b dx, that will give me cos of ax plus b over negative a. This is exactly the same as negative 1 over a times negative 1 over a times by cos of ax plus b. Cos of ax plus b. And we add a constant. So there you go. So let's just go through an example. So let's say we integrate sine of 3x dx. Now in this case is ax plus b. So a is 3 and b is 0. That's why 3x plus 0. It's just like 3x. So we apply the rule. We know that integrates of sine of ax plus b dx, that will give me 1 over a, but it's negative. Okay, so negative 1 over a cos of ax plus b. But in this case here is b is 0, so we just ignore that. So 1 over a is 1 over 3, but it's negative. So the answer is negative 1 over 3. And then sine becomes cos. So cos of 3x. So 3x, that's it. And don't forget, we need to add a constant. So there you go, right? So let's say if we have a functions, y is equal to tan of ax at b. So dy dx, we use power angle trick. So we differentiate the power. There's no power. So we differentiate the angle. And ax plus b is the angle. So we differentiate this, give me a. So which is equal a. And we times by the differentiate the trig functions. And differentiate tan, that give me sec square. And then just write down whatever that angle is. Okay. So there you go. So now if I integrate this, so if I integrate a sec square of ax plus b dx, so that will go back to this original function here. So that is equal to tan of ax plus b. And if we divide by a on both sides, so let's say I divide this by a and I do this side as well, so this cancel out. So therefore, integrate sec square of ax plus b dx, that will give me 1 over a tan of ax plus b. And don't forget, we need to add a constant. So please keep that in mind as well, okay? So we're going to use this. For example, let's say we want to integrate, let's say negative sec square of 3x plus 5 dx. And this is exactly the same as the negative is a constant. I can just take it out, okay? You don't have to, but I can just rewrite this so you can see it easier, simpler if you like. This is exactly the same, right? And we know that integrate sec square of ax plus b is give us this. So therefore, a is 2. The negative, we just write this down. So instead of times 2, we divide by 2 because a is 2. So 1 over a, that means 1 over 2. And then sec is become tan of ax plus b. So ax is 2x plus 5. And don't forget, we need to add a constant. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So we know that integrate sine of ax plus b dx will give me negative 1 over a cos of ax plus b. And we need to add a constant, of course. So now in this case, a is 4 and b is 0. We can ignore that. And the 3 is just the constant. We can take it out if you like, or you can leave as it is. So we can also write this. It helps you to read a bit easier. So sine of 4x dx. So that will give me the 3 is a constant. I write this down. And we know a is 4 here. So therefore, you times 1 over a, but negative. Okay, so negative 1 over a. A is 4. And then sine becomes cos, which is using this. So become cos of 4x. We don't have b, so b is 0 anyway. So that's it. We add a constant. So don't forget. So now what we do, we just tidy this up. So 3 times negative a quarter becomes negative 3 over 4. So that becomes negative 3 over 4. Cos of 4x, we add a constant, that is c. So there you go. Part B, integrate cos of ax plus b, and then dx, of course, that will give me 1 over a sine of ax plus b at a constant. So we know that a in this case is 6. So therefore is 1 over 6. Okay, but 5 it is the constant. So we just write this down. So that becomes 5 with times 1 over a, because it's 1 over a is 6. And then we go sine. So this is sine of ax plus b. So ax, which is 6x plus b just like -7 or -7. And don't forget, we add a constant. So now what I do, I just go 1/6 times 5. So or 5 times 1/6. So give me 5 over 6. So the answer is 5 over 6. And we just write down sine of 6x minus 7. And then don't forget, we need to add a constant. So there you go. So again, we know that integrate of sine of ax plus b dx, and that is equal to 1 over a cos, but of course it's negative ax plus b at a constant. So in this case here, we have a here is 1/5. So if we divide by 1/5, we flip the fractions, become times. Remember that? Becomes times by 5 instead of divided by 5. And the 2 is a constant. So we times by 1 over a becomes 5. Okay, because we flip the fraction, remember. And of course it's -5. And then sine become cos of ax plus b. b is 0. So we just write 1/5 of x and add a constant. So now what I do, I just simplify this. So 2 times -5 will give me -10. So the answer is -10 cos of 1/5 of x. And we plus a constant. So there you go. Now we need to note that integrate sec square of ax plus b. So dx, that is equal to 1 over a tan of ax plus b plus a c, of course. And we know that a is 5. So therefore 1 over a means 1 over 5. So that is equal to 1 over 5. And then becomes tan of ax, that is 5x plus b. b is just -2 or -2. There you go, add a constant. So there you go. I hope you got all of them correct. And thank you so much for watching. Bye.